I'm very happy to have Astrolight here with us on this campaign, because if you perform testing with two ground stations simultaneous and have a lot of exchange, so that is very valuable to us for this exchange, seeing one large ground station and a small ground station and comparing the different implementation and learning from each other. Just to explain what we're doing here is, we're having the Lithuania 1 optical ground station in the background and the portable optical ground station from Astrolight. And first of all, we are upgrading the ESA optical ground station with an optical communication package. So for the moment, you can only use the station for satellite laser ranging. It is operational since a year, but now we're extending the use to optical communication. And for that, we are performing tests with a satellite that is called a flying laptop prototype. That is a satellite in low Earth orbit with optical communication capabilities, and we are tracking and receiving the light from this satellite.
This test was another milestone in our product development campaign in our optical ground station. So the goal was to verify whether our portable optical ground station can survive the travel with a car, with the airplane from one part of the Europe to another. And after all these vibrations and shocks during the travel, it can still provide the performance we need. During the test, we were able to couple the signal from a satellite laser transmitter traveling 2,000 kilometers away from us down to 5 degrees elevation. And we were able to couple the signal to our fiber, which is basically of a thickness comparable to the thickness of a hair. So you can imagine what precision level we need to sustain for the equipment. So yeah, we're happy with the results.
Fine. Turim galę, va.
Galę.
So this is Astrolight team here at Teide Observatory in Tenerife. We have just successfully tracked the flying laptop satellite down to very low elevations of about 5 degrees and even very windy conditions. We were able to get quite a bit of power into our fiber and track it successfully.
So in the future, optical communication will play a quite dominant role, in my opinion. First of all, for inter-satellite links, establishing data communication for a large mega constellation. So basically establishing a network like we have on ground, just in space. And then the second part is also these links in space need to communicate to ground. And on this aspect, I think Astrolight has a very good position because they're offering competitive optical ground station technology for the new space market.
So the simple reason why Astrolight wants to develop laser communication between Earth and space is that the information throughput that we need from Earth to space and from space to Earth is growing tremendously and will grow inevitably with the expansion of humankind to space. And we want to ensure that we don't have a limitation into the amount of data we can transmit to space or back from space to Earth. Similar as we don't want to have these limitations on Earth. And the revolution that fiber internet has brought to terrestrial internet is comparable what laser communication could bring to space internet. And so our goal is to actually develop this technology so that it can fulfill this objective. Another interesting application is actually related to secure communications. Still, satellite communication plays an important role in secure communication infrastructure for many countries, and we have to make sure that it's capable to resist any jamming or spoofing attacks by any adversaries that might want to do that. And laser communication is fundamentally much more secure than radio communication because it uses very narrow laser beam width, which are very difficult to intercept and jam. So we think that it has also the future in defense applications as well.